Hello everyone, welcome to my YouTube channel IndiaGATE. This is Nandani Sharma, and in this session we talk about graph theory, where we discuss about types of graph and also get questions basis of the graph. Now before starting of this session, if you want new GATE tricks, tips and important points, so please subscribe my channel and click on bell icon for all notification of my latest video. So let's get started. So first is your null graph. So null graph is defined as a graph which have no edges between the nodes. Second is your trivial graph. So trivial graph have only one vertex and one node, that is called your trivial graph. Now come to the undirected graph. So undirected graph is defined as there have no direction in the edges, that is called your undirected graph. And come to the next is your directed graph. So directed graph is graph that defines and that indicates the direction from one node to another node with help of the edges, and we say that direction in edges. Now come to the next graph, that is your connected graph. So connected graph is defined as the connection of two or more graph, that is called your connected graph. Next is your regular graph. A regular graph is defined as the number of degree is same for each vertex, that is called your regular graph. In the given graph here, the number of this node is 2, is also 2, and another is also 2. So this is called your degree of the graph and vertex. So here the number of degree is same for each vertex, that is called your regular graph. Now next is your complete graph. Complete graph contains each vertex connected to every vertex of the graph, and it is also a simple graph which is reflected as and given in the given graph. Here all the nodes is connected to each other, so this is called your complete graph. And next is your disconnected graph. So disconnected graph is defined as no connection between two or more graph, that is called your disconnected graph. It is just inverse of the connected graph. Next is your finite graph. So finite graph, a graph which have finite number of vertex and finite number of edges. In the given graph here, the finite number of vertex is 3, and also finite number of edges is also equal to 3. Therefore this is called your finite graph. Next is your bipartite graph. So bipartite graph is defined as a graph where have two set of elements. First is your x and second is your y. But here concerning thing is that the element of the x have no relation or no connection to each other, as well as the set of y have no connection to each element of the set x and y, but the connection is exist between the element of x to element of y, but not self connected. So this is called your bipartite graph. Next is your planar graph. So there are various properties of the planar graph, but still the given graph is your planar graph because there is no overlap or cross edges exist. So hence we say that it is your planar graph. Next is your multigraph. So multigraph used parallel edge between the two nodes, then it is called multigraph. Now come to the next graph, that is your cyclic graph. So cyclic graph, a graph which makes a cycle, means the starting and ending node is same, that is called your cyclic graph. Next is your acyclic graph. A cyclic graph is defined as which have no cycles. That is called a cyclic graph. And next is your pseudo graph. So pseudo graph contains self loop, and also it is a combination of the multigraph. So this is called your combination of self loop. The graph plus multigraph is called your pseudo graph. Now come to the next, that is your complete bipartite graph. So in the case of the complete bipartite graph, it exists complete connection, and we say that easily it is a combination of the complete graph plus your bipartite graph. It is represented as K, M, comma N, where M is represent set X and N is represent another set Y. So in the given graph here, X is represent the element of the X and Y is represent the set of the element. So here in the set X and set Y, no relation between the same set of the vertices, but here complete connection of the each element of the set X to set Y is exist. Therefore it is called complete bipartite graph. Now next is your NQ graph. So it is represented like Qn, where n is represent your number of integer like 1, 2, 3 and so on. So here if the value of n is 1, then the value of Qn is equal to 2 to the power of n, means 2 to the power of 1. This is equal to 2. So this 2 is represent your number of nodes. So 2 to the power of n nodes is represented in n cube graph. If n is equal to 1, then the graph is make like this, and n equal to 2, then graph is make like this, where the total number of the have 4 nodes. Now come to the next graph, that is your cycles. A cycle graph or cyclic graph is defined as which contains cycle. It is represented like Cn, where n is represent your number of nodes, but here number of node must be greater than or equal to 3, because at least 3 nodes you have to require to make a cycle. So a graph which make cycle means starting and ending point is same, that is called your cyclic graph. Next is your wheels. Here in the case of the wheels, when we adding one vertex, then in the cycles that is make your wheel, means in given W4 and W3, where this node is added and connected to each node of the graph, that is called your wheel graph. Complemented graph. So in the case of the given graph, we can find the complemented graph, means in the case of the complemented graph, we just which graph is exist in the graph G is not exist in the graph G dash, means it in the complemented graph, and which edges are not included in the graph that is shown in the complemented graph. Here the black line is represent your graph edges, but here red line is represent your complement graph edges. Now more defined, G dash is represented like this. It is your complemented graph. Now come to the a table which is prepared by me, which is very important for us. Basis of the gate means I have to analyze that in the gate 2 to 3 questions is asked from this type of table. So first type of the graph is your simple graph. In the case of the simple graph, the edges is undirected and here no multiple edges allowed, as well as no loop is allowed. Next is your multigraph. In the multigraph, type of edge is undirected and here multiple edge is allowed but loops are not allowed. Next is your pseudo graph. So here the type of the edge is undirected and here both things means multiple edges as well as loop both are allowed. Now next is your directed multigraph. So directed multigraph contains directed edge and here multiple edges allowed plus loop is also allowed. Next is your mixed graph. In the case of the mixed graph, there is using of both type of the edges, means directed plus undirected graph, and here both things means your multiple edges is allowed as well as your loop is also allowed. Now come to the next, that is your simple directed graph. So simple directed graph, here the edge is directed edge and here no multiple edge is allowed plus not loop is allowed. And we say that in the case of the mixed graph, here both things are allowed, means your multiple edges is allowed, loop is allowed, but in the case of the simple, here not allowed of the multiple edges and not allowed the loops. Now come to the some questions which is really important and basis of the above table. So first is your, in which graph multiple edges are allowed? So options are option A simple graph, option B simple undirected graph, option C pseudo graph, and option D none of these. So right answer is option C, means third, pseudo graph. Next is your, in which graph multiple edges are not allowed? So first is your multi graph, second is your simple undirected graph, third is your mixed graph, and fourth is undirected multi graph. So correct answer is your second, undirected simple undirected graph. Now come to the next question, in which graph loop is not allowed? So answer is your simple undirected graph and multi graph. Now come to the next question which is asked in GATE. So the maximum number of the possible edges in an undirected graph with a vertices and k components is. So come to the solution of this question. So solution is, the maximum number of possible edges in the undirected graph with a vertices and k component is your, in parenthesis a minus k plus 1 and in another parenthesis a minus k divided by 2, and easily we say that v minus component means vertex minus component plus 1 and vertex minus component is whole divided by 2. Now come to the next question. The number of the distinct simple graph with up to 3 nodes is, there are 4 options. Option A 15, option B 10, option C 7 and option D 9. Now come to the solution of this question. So right answer is option C, means 7. But how? We firstly analyze the solution. So assume that the vertices are unlabeled. The number of the distinct simple graph with one node is 1. That is your only vertex, but the number of distinct graph with 2 nodes is 2, means without s and with s. And another we say that the number of distinct simple graph with 3 nodes is equal to 4, means first is your basis of the no edges, second is your 1 edges, third is your 2 edges, and fourth is your third edges respectively. So therefore total number of distinct simple graph up to 3 node is equal to 1 plus 2 plus 4 is equal to 7, means 7 is your correct answer. Now come to the next question. Let G be an undirected connected graph with distinct edge weight. Let E max be the edge with maximum weight and E min be the edge with minimum weight. Which of the following statement is false? So there are 4 options. Option A, every minimum spanning tree of the G must contain E min. Option B, if E max in the minimum spanning tree, then its removal must be disconnect G. And option C, no minimum spanning tree contains E max. And option D, G have a unique minimum spanning tree. Now come to the solution of this question. So right answer is option C, means option C is your false. Now come to the analyzing the all the options. Option A. So basis of the option A, all the edges where are distinct. So easily every minimum spanning tree of G must contains E min. Basis of the Kruskal algorithm will pick E min first. And option second, if E max is in the minimum spanning tree, then surely its remove must be disconnect G, is that E max must be a cut edge. Now option third is specified that, which is your false option, a minimum spanning tree can contain E max if its removal disconnect G, is that it cut a edge. So this option is false. For example, in the graph G is given below, the edge ECD is a maximum weight edge, but still it present in the minimum spanning tree. So after the removing of this edge E, C and D, so there is not existing the minimum spanning tree. So hence the option C is your false statement. Now option D is defined here. Since all the edge weight are distinct, have a unique minimum spanning tree, that is your true option. Now come to the next question. How many undirected graph not necessarily connected can be constructed out of the given set V equal to V1, V2 till Vn of the n vertices? So there are 4 options, option A, B, C and D. And next question is basis of this above question, that is your maximum number of the edges in n node undirected graph without a self loop is. So there is also 4 options, and correct answer for this is B, means n into n minus 1 by 2. Why? Because we know that here in the case of the maximum number of edges of n node is undirected, then we need of the self-containing approximately and completely n into n minus 1 by 2. Now for more understanding and clarification, we come to the solution of this question. Here in the graph G with n vertices, maximum number of edges is possible is n into n minus 1 whole divided by 2. There are 2 ways for a edge. The edge may appear in a graph or may absent in a graph. So there are 2 options for each of edge. Then total number of graph with n number is equal to 2 to the power of n into n minus 1 by 2. That is the correct answer of this question, which is option D. And now come to the next question, that is your, let G be an arbitrary graph with n node and k component if the vertex is removed from G. The number of components in the resultant graph must necessarily lies between the option A, option B, option C and option D. So correct answer is your option C, because here the total number of resultant graph must be necessarily lies between the k minus 1 and n minus 1. Now come to the solution for more clarification of this question. So maximum component will result after the removal of the node if graph G is a star graph, so which is given below. Now, or we see that a null graph of n vertices is shown below, that is your this graph. In either case, if node phi is removed, the number of components will be n minus 1, where n is the total number of the nodes in the star graph. Therefore, n minus 1 is the maximum number of components possible. Minimum component will result in if the node being removed in a lone vertex, in which the case. Then we got here the number of components will be k minus 1. Therefore, the number of components must be necessarily lies between the k minus 1 and n minus 1, which is your option C. That is your correct answer. Now to the next question. A graph G is equal to B comma E, where B is your vertex and E is your edge. Then satisfy the equation E is less than equal to 3V minus 6. The minimum of the degree of the G is defined as this, and therefore the minimum degree of G can't be. Options are option A 3, option B 4, option C 5 and option D 6. Now come to the solution of this question. So right answer is option D. Here given equation is considered as equation first. Let delta with the minimum degree of the graph. Now delta can't exceed of the average degree of the graph, like delta is less than equal to 2 mod E upon V. This is your second equation. Now substituting the equation first in the equation second, we get delta is less than equal to 6 minus 12 upon mod V. So this is clearly the minimum number of the degree has to be less than 6 always, and hence can't be equal to 6. So option D is your correct answer. Now come to the next question. How many number of graphs on n labeled vertices exist which have at least n square minus 3n by 2 edges? So correct answer is your option D, means summation k equal to 0 to n square minus n whole divided by 2 ck. Now come to the solution of this question. Take the number of edges available in n labeled vertices. So we know that n combined 2 equal to n into n minus 1 by 2, means total number of edges is 0, n square minus n by 2 edges. Now from this we need to choose n square minus 3n by 2 edges, or more up to the edges maximum n square minus n by 2 edges. Now choose the Edges represent the distinct graph on unlabeled vertices. So total number of the graph is given like this. Now after the removing of the solving this equation, we get this equation, and it is shown the option D. So option D is your correct answer. Now next question is, what is the maximum number of the edges in a cyclic undirected graph with n vertices? So options are option A n-1, option B n, option C n+1, and option D 2n-1. So correct answer is your option A n-1. Now come to the next question. What is the number of vertices in a undirected connected graph with 27 edges, 6 vertices of degree 2 and 3 vertices of degree 4 and remaining of the degree of 3? So there are 4 options. Option A 10, option B 11, option C 18, and option D 19. Now come to the solution of this question. So correct answer is your option D, that is your 90. So we know that the sum of the degree of all vertices is equal to 2 into number of edges. So just putting all the edges and vertices, we got here x equal to 10. Now number of vertices equal to 6 plus 3 plus x is equal to 10, then we got 90. So option D is your correct answer. Now come to the next question is, let's say we simple connected planar graph with 13 vertices and 90 edges. Then the number of the faces in the planar embedded of the graph is, there are 4 options. Option A 0, option B 8, option C 9, and option D 13. So in the case of the planar graph, the number of the faces in the planar graph is f equal to e minus v plus 2, where e is represent your edge and v is represent your vertex. So just putting the values here, 19 minus 13 plus 2, that is equal to 8. So option B is your correct answer. Now come to the next question. If all the edge weights of an undirected graph are positive, then any subset of the edge that connect all the vertices and has minimum total number of weight is. So options are option A Hamiltonian cycle, option B is grid, option C hypercube, and option D tree. So right answer is option D tree, because here in the case of tree it never form a cycle. So right answer is your option number D 3. Now come to the next question. Which of the following is true for any simple connected undirected graph with more than 2 vertices? So option A, no 2 vertices have same degree. Option B, at least 2 vertices have the same degree. And option C, at least 3 vertices have the same degree. And option D, all vertices have the same degree. Now come to the solution of this question. So option B is correct, because here in the case of the simple connected undirected graph with more than 2 vertices, at least 2 vertices must have same vertex degree. Since if it is not true, then all the vertices would have the different degree. A graph simple all vertices having the different degree is not possible to construct, can be proved as a corollary to the Havel-Hakimi theorem. Notice that it is possible to construct a graph justify the E, C and D. So right answer is option B. Now come to the next question. Let G equal to V, A be a graph defined sin G equal to sigma ID into D, where ID is the number of vertices of degree D in G. If S equal to T and two different trees with psi S equal to psi T, then there are four options. Option A, mod S equal to 2T. Option B, S equal to T minus 1. Option C, S equal to T. And option D, S equal to T plus 1. Now come to the solution of this question. So, given psi G equal to sigma ID into D is equal to sum of the degree. By handshaking theorem, G equal to 2E, where EG is the number of edge in the G. If S and T are two trees with psi S equal to psi T, then putting the values like 2 ES equal to 2 ET, where ES is represented the tree S and ET is represented the edge of the tree T. In the case of the ES is equal to S minus 1 and ET is equal to T minus 1. Now putting the value in the above equation, we get here S equal to T, means mod S equal to T, which is your correct answer. Now come to the next question. Let G be a complete undirected graph on 6 vertices. If vertices of G are labeled, then the number of distinct cycles of length 4 in G is equal to. So there are four options. Option A 15, option B 13, 30, option C 90, and option D 360. So what is the correct answer? So correct answer is just putting the values here, giving the vertices and giving the length in the formula, like n combination with L, that is your length, into L minus 1 factorial. So here n is your 6, combination 4 and 3 factorial. So after the solving this equation, we get here option C is your correct answer, means 90 is your correct answer. Now come to next question here. Consider an undirected random graph of edge vertices. The probability that there is an edge between a pair of the vertices is 1 by 2. What is the expected number of undirected cycle of the length 3? There are four options. Option A 1 by 8, option B 1, option C 7, and option D 8. Now come to the solution of this question. That is your option C is correct, means 1 by 8 is your correct answer. Now come to the solution of this question. We need to find unordered cycle of length 3. So we choose any 3 vertices for 8 vertices. This can be done in 8 combination by 3 ways. To make cycle, we need to choose edge between the selected vertices. Probability of choosing of any edge is 1 by 3. So 3 edges is equal to 1 by 8, and expected number of cycle is equal to NP, where n is equal to 8 combined with 3 and p is equal to 1 by 3. Now putting the value of n and p in our equation, means expected number of cycle, and we get here 7, which is your correct answer. Now come to the next question. Which of the following statement is true? There are two options statement basis of undirected graph. First statement is P, where P is represented the number of the odd degree vertices is even, and Q is represented sum of the degree of all the vertices is even. So which statement is true? There are four options. Option A only P, option B only Q, option C both P and Q, and option D neither P nor Q. Now come to the solution of this question. So basis of the Hens-Seeking theorem, hence of Q statement is true and P statement is also true. So both is true, means option C is your correct answer. Now come to the next question. Let G equal to V be a directed graph with V is the set of the vertices and is the set of the edges. Then which one of the following graph has same strongly connected component as G? So there are four options: option A, B, C and D. Now come to the solution of this question. So here G equal to VE is directed graph. So G2 equal to V comma E2, where E2 is equal to in the parenthesis U comma V, such that V comma U is belong to E, and G and G2 has same strongly connected component. Only the different in G2 there that all the edges G have the reversed the direction. So option B is your correct answer of the question. Now come to the next question. The maximum number of the edges in the bipartite graph on 12 vertices is. So here solution of this question in the case of the bipartite graph, total it is represented like K M into N. So where M is represent set A and N is represent another set. So there are 12 vertices, means 6 for each vertices, means set, means 6 element in the set M and 6 element in the set N, means 6 vertices in the N and M both. So total number of combination of both bipartite graph on the vertices of 6 is 36. Now come to the next question, that is a cycle on n vertices is isomorphic to its complement. The number of n is question mark. So here fill in the blanks is given type questions, and it is a numerical type question where no negative marking. So this is very advantageous for this question, where in the GATE paper there are no negative marking for numerical type question. Now what is the answer of this? Know that isomorphic its complement is n into n minus 1 by 4. After the putting the value of n, we get 5, means here 5 is correct answer. Now come to the next question. If G is a forest with n vertices and k connected component, how many edges does G have? There are 4 options. Option A, floor n divide k. Option B, ceiling n divide k. Option C, n minus k, and option D, n minus k plus 1. So correct answer is your option C, n minus k. Now come to the next question. Consider a binary tree T that have 20 leaf node. Then the number of nodes in T that have exactly 2 children are. So it is fill in the blanks type question. So here what is the total number of the nodes? So here total number of node is n minus 1. So correct answer is your total number of leaf is your 200 minus 1, that is your 199. So correct answer is your 199. Now move on next question. Let G be connected undirected graph of 100 vertices and 300 edges. The width of the minimum spanning tree of G is 500. When the edge of the each edge of G in the increasing of 5, the weight of the minimum spanning tree is becomes blank. So come to the solution of this fill in the blanks type question and numerical type question. So here we know that v equal to 100 as given and equal to 300, and the weight of the minimum spanning tree is 500. Now the number of vertices in MST, the number of the vertices is always 100, but the number of edges is 99, means it may be less than one of the vertices. Now if each edge of G is increased by 5, then minimum spanning tree weight is increased for each of the old minimum spanning tree increase with 5. So total number of 99 edges, so 99 into 5 is equal to 445 is increased. Then total number of new MST means minimum spanning tree is equal to 500 plus 4 and 445 is equal to 995 is your correct answer. Now this session is ended. I hope you understand all the points. If you have any query, so please comment me. I try to resolve your problems. Thank you for watching.